Welding residual stress simulations of industrial-scale components can take months, even years, to get high-fidelity prediction for design and optimization. For example, a mock-up nuclear power plant dissimilar metal joint would take years to simulate full 3D with today's commercial codes. People have tried 2D axisymmetric models, but simplification by 2D axisymmetric model is unable to capture the 3D nature of residual stress field at locations critical to the integrity of welded structures. One way to speed up the computation is to use parallel computing techniques on multi-core HPC computers. However, commercial codes do not scale up well on multi-core computers. Here is our solution, DR-Weld, or Digital Reality Welding Simulation. DR-Weld takes full advantage of modern GPU-based high-performance computing hardware. It uses explicit finite element method, which has excellent scalability on GPU-based numerical solvers, and incorporates a proprietary patent-pending acceleration scheme based on years of experience of welding simulations at ORNL. DR-Weld has a comparable accuracy with commercial software. DR-Weld is easy to use. It is designed to work with common commercially available FEM-based pre- and post-processors to build models and display results. This example of single-pass pipe welding demonstrates that DR-Weld is more than 100 times faster than commercial software. Next are more examples showing the super-fast computation speed of DR-Weld compared with commercial software. This is a 3D simulation of a nuclear reactor pipe system. It is estimated that the commercial software requires around 10 years to complete the simulation. DR-Weld only needs about 3 days.